So no specification of the base. Everyone in the world understands that when you do not specify the base, it's because default is 10. So when you see in your calculator one key, que es called LG, is because it's this kind of logarithm. Okay? This is the common. Okay. But we have another. We have another kind of logarithm that is called natural. Natural. Logarithmic. HMS. Natural. Natural is another kind that the base is equal E. And E is irrational number. It's a famous irrational number. Okay? This is called, in mathematics they are famous irrational numbers. For example, pi is one famous in geometry, and E is super famous in logarithmic. And the definition of the E is a little bit weird. E definition is a little bit weird. It's one expression. It's equal. Definition. I want to copy it. I try to explain. Look, it's using limit. Limit is, evaluate the function, but not exactly on the points, close to the point. It's the only thing. You see when you take calculus and detail the idea for the limit, but it's relatively easy to understand because it's evaluate the function at the point, but not exactly in the points, in the neighborhood. It's very, very close. Entonces 1 plus 1 over x raised to the x power. Okay, this is the definition. Nobody understands anything, but the important thing is that this is approximately in decimal approximation 2.7182818 and because it's irrational number, and you know that the irrational number have infinity non-repeated decimal places. Okay. Okay, professor, but what is important? Natural. Natural is important in calculus. Because in calculus, you can see more clear the fantastic property for the natural logarithm. Entonces, normally, for example, in science, physics, chemistry, we are using common because it's countable and it's more clear to understand. However, in calculus, the student can need to take calculus using frequently or often natural logarithm. Okay, and what is the symbolic way? One of the symbolic ways is logarithm base AE of x. No, nobody write like that. No, everyone write like that. LM of x. So you see, for example, in your calculator, another key, que es LM. Here. LM. LM means natural logarithm. This is the key for the natural logarithm. And this is the key for the common logarithm. Okay? And we use them both. We solve the problem using natural, we solve the problem using common. Either way, you indicate me what do you select, student. So you say, no, we're using common, we're using natural. Okay? Okay, entonces immediately, I want to study in detail the property for the logarithm. The property que allow me manipulate the equation, solving the word problem application. Property of logarithmic. Okay. The first property. Okay, some property we studied before. The first property is the logarithm of any base of 1 is 0. Okay, guys, regardless the base, see the base is 2, see the base is 10, see the base is e, you know, for example, you put in a calculator logarithm of base 1 is 0. I omit the base because I suppose que es 10, it's common. OLM of 1 is 0. OLG, sorry, base 2 of 1 is 0. So, and this is the classical, this is, remember the famous 1,0 point, que is the universal point of the logarithm. Okay, logarithm 1 is 0, keep in mind, everyone. Number 2 property is logarithm of any base of the same number, so they are perfect coincidence in between the number and 1. Okay, entonces basically logarithm base 10 es 1. ln of e es 1. log base 2 of 2 is 1. Okay, when they are perfect coincidence with the base and the number inside the argument, the answer is 1. We're using frequently this property, okay, in the problem. Look like easy, straightforward. No, it's not. It's not straightforward. Okay, let me erase everything. This is totally complementary. Okay, the property number 3. Number 3 and number 4 is similar, very similar. Very similar. Let me explain. I want to copy both. Yes, explain. Suppose log of the base a of the 1 exponential is equal identity function. Or in opposite direction is a exponential. Entonces in the argument of the exponential I copy logarithmic base a of x again is identity function. And this is logical. Okay, this situation happens because we study in detail, and when you have any function, composition is inversed. It's a coincidence that the order is not important, and also it's equal identity because they are inverse function. And when you put together in this composition on those each other, okay? Doesn't matter que you apply, for example, in this case, exponential is first, composition logarithm. Okay, in this case, exponential is first. Okay, exponential is first, and the inverse is logarithmic, right? In that order, or in that order, logarithm is first, and exponential second. Those each other, and the answer is the only difference is in this case, this is a small detail. Okay, this is for all. This is for all real number. It's logical because remember that when the first function is the exponential. Remember the exponential is nice function. The domain is all real number. This is the reason that the exponential first accept any number, and the logarithm do not accept negative number, but I know that the exponential never is negative. Okay, remember the graph of the exponential, or something like that, or like that, depending if it's decay or growth. But we have a boundary here, that is the horizontal axis, that don't allow that the curve go to the negative part. So the answer of the exponential is completely positive. So suppose I put in one example like that, 2 to the x power equal -5. This is a stupid equation, no solution, because the exponential never is equal negative. No, and not zero. And not zero, only positive. No. Okay, in this case, no, because logarithm is piggy. Remember, logarithm of the domain, this was the domain of the exponential, but the domain of the logarithm is domain is parenthesis 0, infinity. So the logarithm only accept inside the argument positive number. Negative is illegal. Logarithm of negative number, illegal. Logarithm of the any base, I don't care, of the negative number is to be undefined. And logarithm of 0 is also undefined. Look, it's similar to this idea. Logarithm of 0 is also undefined. Okay, but in opposite sense, no? Therefore, in this case, x. The answer is x for all real number. But in this case, x, but only for this number, is all positive. See you for all positive numbers. Okay, this is important. We are using this, I promise, in your moment. Well, right now, okay, the property 5, the property 6, and the property 7 is the collection, this super important property. The first property, number 5, say the logarithm of any base of the one multiplication two expression I want to call m times m, you can split like that, like m plus m. So that's fantastic because logarithm, remember the idea behind the logarithm is the exponent. So the answer for the logarithm is the exponent. Remember, the definition is what is the exponent? It's necessary to write the base in order to get one result, no? Entonces, the manipulation, the algebra or the arithmetic behind the logarithm is the exponent, no? And normally, when you multiply two things, you know very well that the exponent is addition, no? Therefore, that is the reason that the exponent, que es the logarithm, is addition. So in your mind, associate multiplication inside the argument of the logarithm as addition too. Suppose this is fantastic because look, we can expand in that direction. We can expand one complicated expression in several elementary expressions using this idea. Or in opposite direction, you can condensing because we have, suppose we have several logarithms. Suppose you have 8 logarithms and you condense it in only one. And only one, que is the multiplication, any expression. Okay, Okay, complementary to this property, we have division. When you divide inside the argument, you have m divided by m, a subtraction. Because you know that when you divide to exponential, no, the property for exponent, no, is a subtraction. Now subtraction, so the minus m is the top part, and the subtraction is the bottom part. Okay. At the bottom part. Okay, number 7 is similar. But in this case is, you know, when you have exponent. And number 7, in my opinion, well, numbers 5, 6, and 7, but 7, fundamental 7 is the most important in my mind. You have, for example, logarithm base a of the one arbitrary expression, I call m, raised to the r power. Power is the exponent. So magically happen that this r gets exponent, go to the front as a factor. This is the guy. It's important. Some people omit that. When you write log, okay, and you put here one thing without parentheses, this is not wrong, but this is not clear. Because remember, this is the name of the function. It's suppose you put f of x like that, without parentheses. No, this is function notation. It's mandatory put the parentheses. Okay? Logarithm by a of m. Okay, entonces I take advantage this property because it's fantastic. Because we have, for example, exponent, and this exponent fly outside. like a factor. And this allows me solving exponential equation because this property converts exponential equation to linear equation. Or no, not necessarily linear, maybe quadratic, but in another easier. This is magical. So the thing we are doing for the solution, for example, this equation is 2x equals 4. Remember when you solved this equation in the last lecture, if we put together using common base, therefore the solution is x equals 2. And then you can apply this equal 3. 3 was impossible. You remember this example, right? It was the motivation to give me introduction to the logarithm idea, no? We cannot solve this. However, using this property, magically, this is magic of the mathematics. You apply logarithm of both sides. And logarithm is one-to-one function, so we can do that. And you apply the property number 7, and this x fly outside. Okay. In that moment, we have in my hand no exponential equation anymore. No. This is history. When the unknown is in the exponent part, no, out of the unknown is just a factor. You solving is similar to the equation 2x equals 4, no? You divide by 2, and in the story, x equals 2. In this case, no, because, well, you see, maybe the students sometimes confusing, well, logarithm of 2. This is just a number. This is just a number that we can compute in the calculator. Okay, so the answer is log of 3 divided by log of 2. And how you solve this? Well, you put in a calculator. Let's do it now. Let's take advantage. Okay. Let me explain the central idea. The central idea is logarithm. Now we discover that we can solving the complicated exponential equation in which we cannot put the common base. We cannot find common base. No common base. However, apply the property number 7 or their combination of the property. You see in more complicated cases, this is elementary. You apply logarithm of both sides, and when you apply logarithm of both sides and you apply the property number 7, you convert the new equation in no exponential equations. You know, in algebraic classical linear equation maybe. Okay, now. Okay. So what is the answer? You leave it like that. You leave it like that if you want. This is the exact answer. However, sometimes in the real life, we don't need the exact answer. We need the approximate answer. We need the approximate answer. So that is the moment that we're using the calculator. And you put in the calculator. Okay, you put it off on the calculator. You press the key log. You put 3, close the parenthesis, division, log again, log of 2. And press enter, and close the parenthesis, press enter. Bam, yeah, get the answer. You get the answer? Help me, guy. Where's the answer? Do you see on your display? Typing in the chat. Come on, this is important today. Everyone working with the calculator, and you give me the answer. Huh? Hey, what exactly, Yasmin? Yasmin say 1 point. I want to copy exactly I see in my display. Que no necessarily is equal your display because the calculator have some differences. Okay. Super. 94, 96, 2501. Entonces my display is truncate. Boom. 1, 2, 3, 4, 5, 6, 7, 8, 9 digit after the decimal point. Okay. Okay. However, in the test, I specification when I want the approximate answer using 4 decimal place. Maybe. No, not necessarily 4. So I specify in the decimal place. In the question of the test, how many decimal place you have. So when you round 1, 2, 3, and 4. So you analyze the next digit, gets 6, gets greater than 5. Now you increase it. So my final answer is approximately after the round is 1.5850, no? Because when this number is equal or greater than 5, you increasing 49 plus 1 is 50. That is my approximate answer according to this criteria. Round for 4 decimal place. Everyone follow me? Everyone follow me? Today we practice this a lot of, okay? Today we practice. Okay, Yasmin. Now, the last property, que in my opinion is the most important property, the name is chain of base formula. Okay, let me copy. Yeah, I want to explain it there. Suppose log base A of x is equal log b of x divided by log b of a. Okay, what is the idea behind this formula? Well, suppose the example that we were doing before. Suppose I want to compute a logarithm of base 3 of 81. In the last class, we are in the jungle without calculator, no calculator. So we are doing by hand. And by hand is, well, I have no idea. I put x. I convert this statement to exponential. The base is 3. The exponent, I have no idea. I put x and 81. I discovered that 81 is 3 to the 4th power because 81 is 9 times 9. Okay, 81 is 9 and 9. And 9 is 3, 3. 3, 3. Actually, 81 is formed by the multiplication 4, 3. Now we discover the conclusion is then x equals 4. Okay, x equals 4 because this exponent is equal to this exponent. This is the way that we are doing in last class. However, I want to use this fantastic formula. This fantastic formula. And this formula allows me, using the calculator, compute any logarithm. So after this class, you have no excuse to compute any logarithm. Suppose again, this example, why not? So the interpretation is logarithm of base 3 of 81. Well, base 3 is non-standard base. This is not possible doing in the majority of calculators. Some calculators, yes, but the majority of calculators, no. So we convert to standard. So A is the base que es non-standard. And B is another base que I select because I want. Frequently, not always, but frequently is standard. And suppose que I use in common log of 81 divided by log of 3. Please help me with the calculator, please. Please, everyone, put it in your own calculator. log 81. Okay, be careful. And this is the display of the calculator. Be careful. You put log. Automatic when you press log in your own calculator. Look. The calculator open the first parenthesis. And you put 81 and close the parenthesis. I did the top part. Division. log 3. Press enter. log 81. Close the parenthesis. F4. Jasmine dice F4 divided by log 3. F4. F4. F4 is equal 4 in our calculator. And we don't need to doing this process que sometimes is confusing. In this case was easy, but in other no. And then you have no excuse to do with calculator any logarithm. Okay, not necessarily 81, another logarithm, right? Entonces, I have a question. Suppose que, bueno, okay, professor, I understand, but I can use natural. I can use a natural. Okay, instead of select common logarithm, que es estándar, que I have in my calculator, I select natural, que es also standard, and I have in my calculator, no? What do you suppose que is the answer? So I select the base B like E. Therefore, we are working with the standard. Suppose that you make a decision to perform the same problem, but using natural logarithm, no common. ¿Es the same answer or is different? What do you think? What do you think? Put in the calculator, please. It's the same. It's obvious. This is the beauty of the mathematics. Mathematics is exact sign. You are doing well in different direction or different method. We get the same answer. Okay? Do you understand very well the change of base formula? I promise that in one moment we can use it, this formula. Okay, just let's practice a little bit, not too much, the property. Let's practice a little bit. In this case, we have two basic operations. We expand or we condensing. For example, example one. Example one is, okay, we have several logarithms. So suppose logarithm base 2 of m plus logarithm base 2 of m minus 4 times logarithm base 2 of a minus 2 logarithm base 2 of b. And they want que you condensing. O sea, condensing is the action in which you express it, this long expression as a single, o sea, only one logarithm. Log something, log, very important to say something. The base must be the same. To apply any property, we need that the base is the same. If the base is not the same, we cannot apply that property. Well, we can, but one more sophisticated, because you need to use in the chain of base formula, use chain to the any same base, so we are ready to apply the property. Okay, we use the property 5 and 6. Sean say we use the property 5 and 6. Very well. And the 7 no. And the 7 no. Okay, you using the property 1, property 5, Sean say property 6, and property 7 no. I suppose que yes, because we have a factor here, and this factor we can put in the like exponent, no? It's important to say something. For example, when you condensing, normally the power you express or the factor you express as a power. Entonces, wait. Property number 5 say multiplication. Property number 6 is division. And property number 7 is a power, no? Care about power. Okay. This is division and multiplication. Okay, so I put the parentheses, I put the line que indicate division. Don't forget the parentheses always when we're talking about logarithm. What guy is in the top? What guy is in the bottom? One of the positive stay in the top. M times M. In the bottom, the negative. The negative is A to the 4th power times B to the 2nd power. Something like that. Make sense or is confused? Make sense or is confused? Understand? Okay. Let's do it in opposite direction. This is super easy. The problem in the test, you see 2 questions like that. 2 questions in which you condense it or expand it, depending on the problem. Suppose that we have now log, no specification of the base because I suppose it's common, and we have m to the 5th power time. Can you scroll up a little? Yes. It's okay? Too much? Okay. M n to the a power divided by x to the 6th power times y to the 7th power. Entonces the idea is completely opposite. I want to expand, and when you expand, wow, you convert the power as a factor. So basically, you apply the property number 5, 6, and 7. Okay, Sean. Okay, so now I put the top part like a positive, you know? It says log m, but the exponent 5 I put as a factor in the front. Don't forget the parentheses. Plus a times log of m minus 6 times log of x minus again, because everything in the denominator is negative, 7 log of y. That's it. Super easy. Super easy. Do you need another example to understand this or no? Or everything is clear? Yes. Everything is clear. Okay, now application. No, another example. Yasmin dice another example. Okay, Yasmin. Of the expand or condensing? What do you consider? Okay, look, I have one here. Okay, maybe it's interesting. Example 3. Is logarithm base 18, non-standard, of 7 radical m divided by m. Entonces I want, again, similar to the expand, no? Actually, inside the parentheses, we have 1, 2, 3, no? 7 radical m and m. So basically, we break it down in 3 logarithms, no? One can include 7. Another gets positive because in the top, everything in the top is positive. Logarithm base 18 of m, but the exponent is the square root of 1/2. So in my mind, I know that it's m to the 1/2. Therefore, I put 1/2 here. Minus logarithm base 18 of m. End the story. Any question? One more example or no? Okay, so let's move on to the application. In the application, we study in detail in what part I'm using this property, no? Okay. So this property we are using, I anticipate something for solving exponential equation and logarithmic equation. Pero bueno, let me start for exponential. Pero exponential, que we cannot solve it by the traditional way, Que the traditional way, remember, is when you express it both sides using the common base. It's impossible. We did before. And the equation 2 to the x equal 3. You remember, right? In this case, it was impossible doing by the traditional way, and I am doing by sophisticated way, que is apply logarithm of both sides. Let's bring another example. Suppose example, I don't know, que is 5 parenthesis 2 to the x equal 8. Okay, this is an exponential equation. A, we can express it like a power of 2, but of 5, I don't know exactly what I'm doing with the 5. Entonces no, definitely no the traditional way. You isolate the exponential. You now apply logarithm on both sides. What kind? Standard, of course. So far, it's okay. Now, in this moment, you apply the property 7. Property 7 allow me this exponent go to the front, like that. Logarithm of 2 is equal logarithm of a over 5. Does it compare this equation and this equation? This is exponential equation. And this is a linear equation. No exponential equation anymore. This is magic or no? It's unbelievable. This is the beauty of the mathematics, right? You have complicated exponential equation. You apply logarithm, que is one tool that we study. And you convert to a linear. A linear is super easy. Linear we study in intermediate algebra. Entonces, logarithm of base a over 5 divided by logarithm of 2. And now we use a calculator to compute that and express it. Okay. Let me try. Everyone working with the calculator. This is part of the game of today. Practice a little bit calculator. Logarithm of a over 5. 0. Okay. 0.6780. Okay. Divided by logarithm of 2. Okay. Boom. I want to copy everything, every digit. 0.678071905. And the test, I want 4 decimal place, round. So 1, 2, 3, 4. The next digit is 7. 7 is bigger than 5. Now you increase it. So the answer is 0.6781. This answer is perfect. However, this is the answer I want after you round to the 4 decimal place. Okay? Any question, guys? No? Let's move on to the little bit more complicated problem. Suppose this example. This exponential equation. 0.3 raised to the 1 plus x is equal 1.7 raised to the 2x minus 1. Wow! This is exponential equation, contains 2 different bases, 0.3, 1.7. This is impossible doing by the traditional way because you never can express at 0.3 and 1.7 using common base. No, illegal, completely impossible. Now this is a classical example. You solve them by logarithm. You apply logarithm on both sides. What kind? Standard, of course. I know it's standard because we finish in one expression. You can find the exact answer or approximate answer depending the question, no? So you apply logarithm of both sides. I suppose common or natural. The answer doesn't change. I prove that do not depend of the logarithm we use. Entonces, one more time you apply the famous property number 7. The famous property number 7. And this entire exponent go to the front. And this go to the front. Okay, so we have 1 plus x. Be careful. You put a parenthesis. Multiplication by log 0.3. Is equal. Do you understand it's important to put the parenthesis, right? Because this entire expression multiply this, because this is just a number. It's a weird number, it's irrational. Normally, the answer for the logarithm is maybe is no multiple or power of the base 10 to say it's irrational. Here is 2x minus 1 multiplication by log 1.7. Okay, in this moment I am guarantee you that this is a linear equation, not exponential equation anymore. No. And you proceeding exactly the same we are doing in intermediate. Distributive property. 1 times logarithm 0.3 is logarithm 0.3. X times logarithm 0.3 is x times logarithm 0.3. On the right hand side, exactly the same. 2x times logarithm 1.7 is 2x times logarithm 1.7. And negative 1 is negative logarithm 1.7. Okay, linear equation. You manipulate both sides in order to isolate, solve for x. There are many strategies. I don't know. I need to make decision. For example, this guy stay here. Okay, I move this to the right. Because my goal is somehow grouping the x. I put a term that contains x to the right hand side. Maybe, no. It's one possibility. And this stay here. And this plus logarithm 1.7. Okay, good. Now why no? And the right hand side I can see that x is a common factor, so I factor out. Entonces we have 2 times log 1.7 minus log 0.3. And the right hand side and the left hand side, sorry. Why no? I highly recommend condensing. Not necessarily put in the calculator 2 times logarithm 0.3 plus logarithm. No. You save time if you condensing like a logarithm. Entonces you apply in this moment the property number 5, no? Que es basically 0.3 times 1.7. It's 0.51. Okay, do you see the advantage to do in that way? Okay, I forgot the parenthesis here. We can condense in that part. We can. Of course we can. How? Well, this is subtraction. So you apply the property number 6. Entonces division, no? Es division. But we have a factor here that you convert as a power. So basically, you condense these two logarithms and only one like that. Logarithm is 1.7 squared, because this exponent fly like exponent, divided by 0.3. And don't forget the parentheses, guys. Let me continue. I copied that in my calculator. It's 1.7 squared divided by 0.3. This is logarithm of my calculator is 9.63 repeated. I'll leave it like that, whatever you want. To say, what is my what is my answer? Well, my answer is x alone, isolate x, is log 0.51 divided by log 1.7 squared over 0.3. And this is the x value. Now calculate. Well, this is the exact answer. Good. This is the exact answer. Oh, using this or using that number, it's equivalent, no? It's the same. And I want the approximate answer. Again, round to the near to 4 decimal place. Does I need help? I need help. Everyone using your own calculator. 0.51, 1.7. Oh, negative, negative, it's negative, it's negative. Oh, exactly, negative, negative, it's negative 0.29, 75 or 73? It's 73? Yeah. Okay, this is the answer. One important thing, my opinion, one important thing. Okay, this number is 0.51. It's less than 1. And what happens when you compute logarithm of the number less than 1? It's negative. This guy is negative, for sure. This guy no, because this number is 9 point something. Look at that. 9.63 repeated. And the logarithm of the number greater than 1 is positive. So this guy is negative, this guy is positive, and negative divided by positive is obvious que es negative. That is the reason que the answer is negative. Make sense or no? Make sense or no? Yes. Entonces, for no surprise, I highly recommend que you analyze the number que you involve in the problem, no? Si es positive, si es negative, si es greater than 1, less than 1, to predict a little bit the okay. I have another a little bit more complicated exponential equation. Remember, guys, we have two kinds of exponential. The classical, the traditional, que we can manipulate both sides. Okay, this is not necessary to apply logarithm. No. Yeah. Well, it's possible. Yes, always logarithm is universal. Logarithm is universal. But in this case, no. More comfortable is expressing both sides using the common base. And another kind que es mandatory using logarithm. Okay? Okay. Suppose this example. 4 to the x minus 10 times 4 to the minus x equal 3. A little bit more complicated. Okay. Exponent negative, wow. Okay, exponent negative es reciprocal, ¿no? Entonces, you can write like that. It's another way to express the same idea, no? But I don't like denominator. So I propose you multiplication whole thing by 4 to the x, because I want to remove somehow 4 to the x, que is the number in the denominator, or the expression in the denominator. 4 to the x times 4 to the x is 4 to the x squared. Minus, this is cancelled, that's the most intention. This is 10. And this is 3 times 4 to the x. At least for me, it's more clear. Okay. Entonces, I realize in this moment que this equation is quadratic in front. Remember, quadratic in front is equation que contain one expression, another expression, but the exponent here, exponent 1, exponent 2, exponent 1, que suppose que es the bigger, is twice. It's twice. In this case, the exponent, okay, actually this is for 2x. So using the property of the multiplication of the exponent, minus 10, is equal to 3 times 42x. So this exponent is 2. It's twice this. Entonces, we can convert this equation to quadratic equation. To see a quadratic equation, first of all, I want to move everything to the left. Y ahí, using the substitution u equal 42x. It's a smaller exponent, ¿no? Entonces 0 is equal minus 10 minus 3u, by definition was u, my definition, and this is u squared. Wow. In this moment, we have a quadratic equation. Super easy, solving by factorization or quadratic formula, either way. In this case, by factorization, I suppose it's super easy because the combination is 5 and 2. 5 times 2 is 10, 5 minus 2 is 3, negative 5, positive 2. Okay. Now u equal 5 is my first solution, and u equal minus 2 is my second solution. But I feel no. Remember the idea for the quadratic front equation. We have the original complicated equation. You have the original complicated equation, and we are using that substitution. We convert to quadratic. Now, this new variable auxiliary can help me to simplify the problem is u5 and u negative 2. Because I need to get the original variable que is x. No, this is the answer. The u was intermediate guy. Now I put here because I know that the relationship connecting u and x is this. Entonces 4 to the x equal 5. And 4 to the x equal minus 2. Okay, in that moment, we are in front to exponential equation. 4 and 5, 4 and negative 2. It's impossible express it both sides using common base. No, it's totally crazy. Now you apply logarithm. In this case, by curiosity, not necessary, I use a natural logarithm of 4x is equal natural logarithm of 5. One more time, you apply the famous property 7. This x go to the front as a factor, x times ln of 4 equal ln of 5. Divide both sides by ln of 4, x is equal ln of 5 divided by ln of 4. Okay, and this is my exact answer. But normally in the test, no, they want approximation, 4 decimal place or 3 decimal place, or whatever, blah. In this case, 4 decimal place. Put in the calculator, please. Today is the day to practice calculator. No, Yasmin, another participation. Come on. Come on, guys. Oh, let me see. Jennifer, you bring calculator. Betancourt, you bring calculator. Bolívar, you bring calculator. Lustin, calculator. Yailin, Yancy. Cesar, you bring calculator. Sean, calculator. Lauren. Okay. Yancy say. Okay, Yancy, give me the answer. What is the answer in approximate way? Queen, calculator. I have a calculator. Who? Sean, I have a calculator. And Guerra, Lauren Guerra. and Queen Prosser. Okay, who there? Come on, Frank. Who there to give me the answer? Type it with the chat, of course. No? Logarithm of 5 divided by logarithm of 4. That's it. What is this? Okay. See, it's confusing for you, natural. And in the calculator we have, this is the answer. The answer is 1.1610, ¿no? Suppose que you are not familiar with the natural logarithm. Okay, ln, we can use log, it's the same. The answer doesn't change if you using either logarithm, common, natural, or another. Okay. This is one solution. And what do you think about the second piece of the solution? What do you think about this? What do you think about this guy? Oh, no difference between. No, Sean, you're right, mister. No different. It's the same. I illustrate one example. Remember or no? Okay. Now we can use it. I don't know why I select ln in this example, because I want to illustrate this idea, no? But if you're using log, please practice, Sean, solving by both way, using ln or using log. Let me try my calculator. 5 divided by 4. Boom. Yes. All right, 1, 2, 3, 4. Yeah, you're right. 1.1610. That's the answer. Oh, super. Okay. Okay, entonces I ask a question you. What do you think about this statement? 4 to the x equal -2. What should I do? Same or no? So basically, we are in front of this exponential equation. What do you think? We using exactly the same or no? Why not? Okay, Sean this, we are doing the same. Okay. I agree partial. What do you think about exponential function? Let me recall something. Exponential function look like that. Exponential function, I remember, can have horizontal asymptote at y equals 0. Therefore, horizontal function, regardless what base is 4 or is 2 or is whatever, is in this case 4 is growth exponential, it's increasing, no? And -2, it's like that. The line y equals -2. This exponential function and this line never intersect. In other words, exponential never is negative. Therefore, this is a contradiction. Therefore, this equation, I prediction, okay, we have no solution. Pero suppose que you don't know anything, or you don't realize this idea. No solution. Okay, no problem. I try to do my best. I apply exactly the same procedure. I apply logarithm on both sides. What kind of LOG do you like? Okay. I'm using the property number 7 one more time. 7 logarithm of 4 equal logarithm -2. Now 7 no, carajo, x, que es this one here, x. Therefore, x is equal log of -2 divided by log of 4. What do you say about logarithm of the negative number? Suppose I try to compute that. in my calculator. Log -2. Boom. I say what matches here is domain error. Domain error. That makes sense because remember, the domain for the logarithm is only positive number, no zero, no negative. Okay? Only positive. It's the domain. One more time with confirmation this idea. No solution. Using another point of view. No? Logarithm negative is completely out of the domain for the logarithm function. In other words, the exponential function, que es the inverse, never is negative. It's the same thing, but explained in a different way. Any question? Any question? No? Okay, entonces I bring here two extra credit problems. No, Sean, no. Okay, Sean asked me. So, logarithm negative number is undefined. Okay, and also logarithm 0 is also undefined. Logarithm only accept inside the argument positive number. That is a reason that the domain is from 0, no including 0 to infinity. And remember, Sean, the logarithm graph look like that. Look. This is a famous 1,0 point. Entonces we have here one vertical asymptote que don't allow the curve, the red curve, passing through or passing inside the negative part. Here we have no logarithm. It's another point of view. I like so much the graph, the geometric interpretation for the thing. Okay? Any question? Okay, entonces I bring two extra credit problem. Two extra credit point. Extra credit. Another extra, but the student can need extra point, extra credit. Extra credit que you solving attached with the test, ¿no? O sea, the test contains 20 questions, entonces 2 extra, 22 questions. Y I grade like a 5 point each. So 5 point plus 5 point. Okay? This is similar. So you solve the first, you solve the second. Suppose this exponential equation. 1 to the x plus 2 to the x equal 4 to the x. And the second is 6 to the x plus 4 to the x equal 9 to the x. Okay, this is a little bit not complicated, but you need to use some imagination. 5 points for this. 5 points for this. Clear? Crystal clear? Okay. Let's move on to logarithmic equation. Okay, when you will be able to solving logarithmic equation and exponential equation, this is a moment that we are ready to apply this thing in the real life applications. Real life application, I don't want to explain separately. No, I want to explain inside the review package. In the review package, I explain some formulas, and this formula we solving, of course, using exponential equation or logarithmic equation. Not necessarily one lecture dedicated for the application. No. Inside the review package, you see exactly the application that you need. Now we are talking about logarithmic equation. Okay, ready. Logarithmic equation. Okay. The first example of the logarithm equation is, suppose logarithm base 3 of x plus logarithm base 3 of x minus 24 equal 4. Please copy the first example of the logarithm equation. So I use identification because we have several logarithms inside the equation. So es equation que contiene logaritmo, no exponential. Es el logaritmo. Entonces, what is the strategy? Always is the same. Always is the same. You condense it. Suppose you have 2 logarithms, 3 logarithms, 4 logarithms, 20 logarithms. You condense it in only one. Then you apply the property number 5. Because I saw que es plus. Since plus, entonces when you condensing, we have multiplication, this expression time this expression. Entonces x time x minus 24. Okay, this parenthesis is exactly the same parenthesis here, but don't forget that we have the parenthesis of the logarithm function, no? Equal 4. Do you understand this or no? Okay, now this is the most important moment. This is the most important moment because in this case, to see more clear, you convert this logarithm statement to exponential statement. Okay, yeah, I think like that. What's the base? Well, the base is 3. So this is small 3, I put big. That's the base. What is the exponent you need to raise? 3. Exponent is the answer for the logarithmic. Always this 4 represents the exponent. And is equal, well, the rest. The rest is x minus 24. Okay, and now we have one new equation that is equivalent, not 100%, is equivalent somehow to the original, that do not involve, no any more logarithm, no any more exponential. Well, no, actually you see exponent, but es que 3 to the 4 power is 81. So actually 81 is equal, and you apply distributive property here, why no? Is x squared minus 24x. Oh, this equation is quadratic equation. Entonces let me write in standard, elegant way. X squared minus 24x minus 81 equal to 0. Entonces I focus in this equation, que somehow is equivalent to the original, and give me the solution. Everyone understand very well this or no? Guy, you follow me or it's confusing? You follow me. Okay. This is extremely important in this chapter. Master the conversion from logarithm statement to exponential statement or backward from exponential to logarithm. So frequently we are doing this in both directions. Okay. Well, I don't know si this equation is good solved by factorization or quadratic form. I suppose the quadratic form is better. A1, B is negative 24, and C is negative 81. Okay, I'm using the quadratic formula. B is negative 24, double negative become positive. Okay, let me make a zoom. Okay, plus and minus, square root, negative 24 squared, minus 4 multiplication by 1, que es 8, multiplication by C, que es negative 81. Be careful with the signs. Divided by 2 times 1. Okay, I focus my attention in the expression inside the radical, this expression. Of course, it's a big number. Therefore, I use my calculator, no? I put 24 squared, doesn't matter. I recommend you put 24 without sign, no? Because I know that the answer is positive, right? This is 24 squared is 576. Be careful with the sign. We have double minus. Double minus become positive. Entonces we have 81. 81 times 4, no? 81 times 4 is 324. And 324 plus 576 is 900. Wish. Nice. And square root 900 is 30. 30, right? Make sense, right? No necessarily calculate, because it's square root 9 is 3, square root 100 is 10, no? Entonces we have so far 24 plus or minus 30 divided by 2. They separate into pieces. The first piece is 24 plus 30 over 2, and 24 minus 30 over 2. Okay. This is 54, no? This is 54. And 54 divided by 2 is 27, no? Okay. And this is negative what? Negative 6. And negative 6 divided by 2 is negative 3. Okay. Good. I finished? No. Why no? Because you, in this new equation that we are studying, is called logarithmic equation, you need to check in mandatory. Check. Why is important? The reason is because the domain of the logarithm function is only positive. Okay, domain is from 0 to infinity, no 0, no negative. It's a set inside the logarithm. Okay. So the negative value, not always, but frequently, is a bad guy. I need to prove directly, plugging in. But no, let me start for the more clear 27. 27, I check in 27, checking for x equal 27, see it's true or no. So basically, logarithm of base 3 of 27. Now we practice a little bit. Computation for the logarithm, no? With calculator or without calculator, either way that you prefer. Plus logarithm base 3 of 27 minus 24 should be, I claim that 4. See, this statement is true, 27 is solution. See, this statement is false, 27 is no solution. Okay? Let me try, and you help me. Okay. Bueno, logarithm, I have no idea. Base 3 of 27 plus 27 minus 24 is 3. Should be 4. Okay. Oh, but I know one property number 2. Remember, property number 2 says the logarithm of the any base, and when the number is the same is 1, no? Okay, entonces this answer is 1. Entonces, to be true, this answer should be 3. So logarithm, suppose que without calculator, I have no idea. I put x. I convert this statement to exponential. The base is 3. This 3 is this 3. Exponent, I have no idea. 27. But I know that 27 is 3 to the third power. Because 3 times 3 times 3, therefore x is equal to 3. And 3 plus 1 is obviously 4. This statement is true. Now solution 27 is perfect. However, what happened with the negative 3? When you try to check in for negative 3, it's crazy, because x equal minus 3, you plugging in here, logarithm of base 3 of negative 3. Oh, it's illegal. Negative number inside. Therefore, this is no solution. And the only solution that we have in our hand is 27. End the story. Solution for this equation is 27. Any question? What part is confusing? The procedure is always similar. Condensing several logarithms in only one single. Convert to exponential statement. And when you convert to exponential statement, magically, we get the equation that is no exponential, no logarithmic, it's quadratic equation or linear equation, depending on the problem. And you solve it using your algebra. But you don't expect that the solution for the quadratic or the linear is 100% equivalent to the original logarithm because logarithmic equations are picky. Do not accept any number. You need to verification, mandatory to see in the test, checking the potential solution into the original equation. And verification is true statement. Any question? Any question? Are you boring? This is good. This you lie. You don't lie. Actually, you believe it's magical. It's good. Okay. Understand. Okay. 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 Let's continue practice a little bit more about the logarithmic equation. Okay. Number 2 example. Number 2 is log base 2 of 3x minus 2 minus logarithm base 2 of x minus 5. Could you plug in the number into the exponential? Could you, come on, repeat again the question, but activate the microphone, please. I have no time to read that. What is your question? So you plug it in inside the exponential?
Hello?
Hello?
I am here. Come on.
I was wondering if after we did the quadratic form, the answers we got from that, we plug it into the exponential form of the original equation instead of with the log.
Good question. Excellent question. Look. Okay. Remember, what is the difference between exponential and logarithm? Exponential, the domain is all real number. However, logarithm, no. It's only positive number, right? Therefore, exponential equation is nice. You don't need to check an exponential equation. If you want, okay, listen. Normally in algebra, always, if you want to check in, so you can, for example, in this stupid equation, 2x plus 3 equals 5. And you want to verification, okay, x is 1. And well, you plug it in, 2 times 1 plus 3 equals 5. And 5 equals 5, okay, true. The solution is good. Okay. This is always positive. But in the, what is the idea behind? The idea is in the exponential equation, never we have a extraneous solution because the exponential equation, the exponential function, a nice function, and the domain accept all real number. However, in the logarithm, no. Logarithm is super sophisticated lady. Okay? And do not accept negative or 0. Therefore, in this case, it's mandatory because my new equation is not 100% equivalent to the original. And this is not new for you. Remember, when we solving the radical equation, we manipulate the equation. You eliminate the radical. End the story, no radical anymore. However, this new equation is equivalent, but not 100% to the original equation. Therefore, in the radical equation, we need to verify because radical function is picky also, don't accept negative solution. Only 0 yes, but negative no. It's imaginary or complex. This is your question, mister?
Yeah.
Thank you.
Okay, thank you. I like this question. Okay, well, help me. I need help in the question 2. What should I do? What should I do? I have no idea. I am totally lost. Please help me. What is the strategy? It always is the same. You have several logarithms. 1, 2, 3, 4, 5. You condense in only one, no? Right? What property are you using? Exactly. Chance property 6, professor. Because the minus. But actually, we condense logarithm base 2 of 3x minus 2 in the top divided by x minus 5 in the bottom. Don't forget the parenthesis guy, equal 4. Super. This is my first step. Apply the property number 6. In this case, condensing, allow me condensing 2 logarithm and only 1. After that, what should I do? It's the second step always. So I want in the test you put an arrow like that. I understand you put 2 exponential. Okay, in this moment we are doing the conversion from logarithmic statement to exponential statement, no? Okay, entonces I ask by myself because the method I am using to convert to exponential, I ask by myself, what is the base? What is the base in this statement? What is the base in this statement? Well, the base is 2, no? And you put the big 2. What is the exponent? What is the exponent representing in this statement? What is the exponent in logarithmic statement? It's 4. The answer for the logarithm always is exponent. It's equal to the rest. And the rest, I have no idea because it's a variable, contain variable. But actually, the thing we are doing is conversion from logarithmic to exponential, but in this case, it's no exponential equation because the unknown, this x, is not located in the exponent part. To the 4 power 16, wow, so you focus your attention on the solution of this equation. It's a linear equation, obviously. The only thing you should do is apply cross multiplication. It's 3x minus 2 equals 16 times x minus 5. And you apply this distributive property. It's 16x minus 18. 16 times 5. Okay. So for x. Now, easy. Well, I propose you 16 stay here on the right hand side. I move minus 3. Okay. And this negative 2 stay here. And this 80. Positive. And the left. This is 78. And this is 13. It's a linear equation. One solution. Divided by 13 both sides. X is equal 4, no? No, 6, sorry. 6. Okay. And that's it. I gotta go. I need to check it. Well, we have only one, no? See this solution failed. When I plug it in the original, so we have no solution, no? But this is weird to happen. Let me try to check. Checking for x equals 6. So basic is logarithm base 2 of 3 times 6 minus 2 minus logarithm base 2 of 6 minus 5 should be 4. Question mark. Okay. We're doing the operation inside. Operation inside is 3 times 6, 18. 18 minus 2, 16. Minus logarithm base 2. 6 minus 5, 1. Equal 4. Wow. Look at that. Logarithm 1, I know a property number 1. The first property I need to remember is 0. Of the any base of 1 is 0. This guy is 0. It's gone. 0. Disappear. And I want to prove somehow with the calculator overhand. Okay, this is 4. Making sense, right? Because 4, 2 to the 4 power is 16. Yeah. It's obvious. What do you prefer? Honestly, in that moment, we are doing by hand or using calculator? Because remember, in the calculator, you never have excuse to compute the logarithm because in our calculator, you put log standard 16 divided by log of 2, right? And you get the answer, right? Another way is, well, convert this to the exponential statement. The base is 2, the exponent is 4. Well, the exponent is 4, no, I have no idea. The exponent, I don't know here. It's x equals 16, but 16 I know. Okay, it's 2 to the 4 power, therefore x is 4. And I suppose that we are doing with the calculator, the answer is 4 also. What way you prefer, this way or that way? By hand or calculator? Eh? Answer me. Calculator. Okay, Sean. Okay. I respect. And you, Yasmin, calculator or by hand? Guys, for me it's important. Your opinion, no? Because I have calculator. Yasmin prefer calculator. Okay. Okay. Super. Okay. Everyone understand very well the example 2? It's 4, yeah, it's 4, absolutely. Entonces 4 equals 4. So we computed the left-hand side of this statement. The answer was 4. And 4 is equal to 4. This statement is true. Remember, we are not solving. We are verification. The solution was that part. We get the potential solution. Potential solution. Now I need to verification the potential solution into the original equation. I verify it's true. If it's true, okay, happy. The solution is 6. The solution for this equation, solution set, is 6. Okay, ready. Let me go one more. Example 3. Example 3 is, I like that. Example 3 is logarithm base 14 of x plus 5 equal 1 minus logarithm base 14 of x. Wow. I don't care the base. The base is not important. Base 14. Okay, entonces the teacher explained me that the step number 1 is condensing, no? Condensing. For condensing the logarithm, we need the logarithm stay is located in the same side of the equation, no? Entonces I put it completely crazy, disorganized. Oh, wait, I don't care. You put now logarithm base 14 of x plus 5 plus because I moved to the left in opposite sign. Okay, equal 1. Okay, this example brings me this new idea. Okay, not necessarily the equation is elegant to start. No, you need to organize. You put a logarithm on one side, left or right, doesn't matter, and no logarithm on the other side. Now you are ready to apply the property number 5. And the property number 5 say okay, logarithm base 14 of the multiplication, this expression and this expression, no, is x times x plus 5. Don't forget the extra parenthesis or bracket, square bracket, doesn't matter. What do you prefer? Equal 1. Now the crucial moment to conversion to exponential statement. Okay. The base is 14. Wow, it's weird. The exponent is 1. 1 is invisible. I don't need to write that. If you want, no? It's equal to the rest. X plus 5 times x. No. X times parenthesis x plus 5. This looks like quadratic equation, no? I apply distributive properties of 14 is equal x squared plus 5x. I organize in a standard form the quadratic equation. Okay, so we have x squared plus 5x minus 14 equal to 0. Wow, easy quadratic equation. Okay, suppose that we can solve it by factorization, no? Not necessarily quadratic equation, no. X. And the factor involved in the problem is 7 and 2. I suppose 7 times 2 is 14, and 7 minus 2 is 5, plus 7, negative 2. The one solution is negative 7, and another solution is positive 2. I suppose that negative 7 down progressing in this example, because when you plug in negative 7, at least here directly, look, this is the original, I never touch, waiting for that moment. Logarithm negative 7 is undefined, so this is no. Not always happen, frequently happen, but sometimes, depending on the problem, suppose that we have here no x, you have x minus 2. Or, sorry, plus 8. When you plug in 7 here, it's negative 7 plus 8 is no negative, entonces maybe progressing. this solution. But depending on the problem. Okay, let me prove que 2 is good. Logging in into the original. So I need to prove somehow que logarithm base 14 of 2 plus 5 should be equal 1 minus logarithm base 14 of 2. Okay. What should I do? Well, 2 plus 5 is 7. No? 2 plus 5 is 7. Logarithm base 14 of 7 should be equal 1 minus logarithm base 14 of 2. Entonces I stuck here because we have again the same situation. Okay, both logarithms are on the different side of the equation, of the statement. Sorry. Now I propose you move to the same side because at least maybe you can condense it, no? Plus logarithm base 14 of 2 should be 1. So one more time, we're using the property number 5 is addition, is multiplication. Entonces basic is logarithm base 14 of 7 times 2, que 14. Wow! And using the property number 2, I know that when this number is exactly the same of this is 1, I prove it's true. Therefore, the solution 2 is perfect. Any question? Any question? Clear? Okay. I have another que bring me new situation, completely new situation. Little bit confusing. Example 4, no? Is 1/3 logarithm base 2 of x plus 6 is equal logarithm base 8 of 3x. Okay, wow, this is hard. Oh, it's different, it's weird because it's the first time you see in one logarithm equation different base 2 or 8. And we have several possibilities, but the goal is clear. The goal is you cannot manipulate in that way. Different base, nobody can do that. So we convert. We convert everything to the base 2 or everything to the base 8 or everything to the standard base. And we can use a calculator. I need to make a decision, no? Entonces, in my paper, I do by everything to the base 8. So I don't touch that guy. This stays the same. And this I convert to the base 2. When you have the same base, it's easy, or relatively easy, the logarithm equation. I try to recall the formula. The formula que es the property A, no? Que es the chain of base formula. The chain of base formula says logarithm of any arbitrary base of the one specific expression is equal to the logarithm of the new base I call B of the same expression. Just copy. And here logarithm of base B. So B is the new one. B is the new base. However, A is the old base of A, no? This is the formula. Compare this idea and try to adaptate to our specific example. Okay. So now you have division because the formula involves division. No? So what is my goal? My goal is convert A to 2. A to 2. It's logarithm base 2 because B now is the new one, is 2. And expression is exactly the same. I don't change this. Divided by logarithm base 2 because the same base B of 8. And A is 8 in our problem. Okay, I convert using the chain of base formula. Okay, so I write like that. 1/3 logarithm of base 2 x plus 6 is equal. I am happy because any logarithm contains the same base. Yeah, I can use another property, number 6, number 5, number 7, 3x, but I need to compute logarithm of base one corner of the paper. I put logarithm of base 2 of a. Help me, guy. Help me to compute logarithm base 2 of a. Using calculator or by hand, either way. Using calculator or by hand, either way. Come on, help me. Help me, Jennifer. Help me, Betancourt. Help me, Bolivar. Help me, Lustin. Jailin. Yancy. Jennifer. Jasmine. Sean. Lauren. Queen. 3. It's 3. You did, Sean, using the calculator or by hand? Calculator, okay. Super. It's 3. So Sean say, okay, the answer of this is 3. They put it here, 3. Everyone is agree or disagree with this 3? You know or you don't know how we get this 3? Sean get 3. Agree or disagree? Agree. Okay. Look. Entonces almost we finish. Almost we finish, because when you discover that this is 3, it's a coincidence. It's obvious that this 3 and this 3 is cancelled. Yes or no? Another point of view to see that if you multiply the entire equation by 3, 3 times 1/3 is 1, and 3 divided by 3 is 1. And we have so far logarithm of base 2 of x plus 6 is equal logarithm of base 2 of 3x. Wow! But in that moment I can see that we have two logarithms. It's similar to, we have two exponential. And the exponent, for example, the base is the same, so the exponent is the same because it's one-to-one function. In this case, it's also one-to-one function. Logarithm is one-to-one function. Remember, I know it's one-to-one because it's the inverse of the exponential. And any function that is one-to-one is invertible. Okay, so now, so you have two logarithmic and the base is the same. It's because the expression inside is the same. And you magically convert the logarithmic equation in one linear equation. Okay, now solving. It's easy. It's 6 is equal to 3x minus x. 6 is equal to 2x divided by 2. X equal to 3. Okay. I need to check it or no? Checking or no? Absolutely checking. Always you have to check it. In the logarithmic equation, always you have to check it. Okay. Check it where? In the original. 1/3 logarithm of base 2 of 3 plus 6 should be equal logarithm of base 8 of 3 times 3 is 9. It's easy because 3 plus 6 is also 9. 1/3 logarithm of base 2 of 9 is equal logarithm of base 8 of 9. And then to compare this logarithm one more time, we're using the property number 8, the chain of base formula. Chain of base formula. Then I did before. Okay, this is logarithm of base 2 of 9 divided by logarithm of base 2, the same base, 2 of A, no? Que we compute before, que es 3. Then we get 1/3 logarithm base 2 of A of 9, sorry, is equal logarithm base 2 of 9 over 3, que es the same. This is obvious que es the same. It's super true. And the solution 3 is perfect. Okay. One more. All right. See, we have time. We have time to one more, and that's it. Everyone follow me? Guys, next time, well, my plan is send to you today the review packet, because the review packet we start, so we spend the entire week next week doing the review package, no? Okay, this is number 5 example. Inside the review package, you see similar situation that we discussed here, but we another can know. The reason is we lost one day, remember, no? But don't worry for this, because when in the solution for the review packet, you see the application, and the application you apply this idea, the property, the equations, logarithmic, exponential, for solving real life problems that involve logarithmic or exponential relationship, no? Okay, so we have 3 logarithms, 1, 2, 3. Wow, what the hell? Okay, one possibility is, well, manipulate separately. In this case, you bring everything to, you can move everything to the left, but no. Much better apply property number 6 here and condensing this and this. Either way, guys, either way. We're using your imagination. Something like that. Equal log 3. Well, something is weird at this problem. I do not specification the base. Why? Why I do not specification the base? Why? Why no? When there are no specification of the base, default you suppose what value? Hey, are you there? Hey, es 1. No! 1 is impossible to be base. It's 10, Frank. Thank you. Okay. Hello. The base never is 1, never is 0, never is negative. You know that. Okay, the base standard is 10 and E. When there are no specification the base, it's because it's 10. When it's E, this notation is transformed like a LM. This log. Okay, the base never is 1, never is 0, and never is negative. It's always positive. Okay, but it's not important. Okay, I know that the base is 10. Okay, now in this moment I take advantage. Okay, we have a logarithmic equation, but this logarithmic equation I can convert to the linear equation because we have 2 logarithms and the base is the same. And I know that it's 1-to-1 function, therefore the expression inside should be the same. And disappear the logarithm. I don't like cross out. This is not good. I don't like. Okay, now cross multiplication. 3 plus x is equal to 3 times x minus 3. 3x minus 9. Let's see, we have 3x here, stay minus x. 3 plus 9. Okay, this is 12, and this is 2. Divided by 2, the answer is 6. Okay, the answer is 6. Okay. I need to check it now. No? Yes or no? Of course, always. And always, yes, of course, always. Mandatory checking. I need to prove somehow the logarithm of 3 plus 6 and the original minus logarithm of 6 minus 3 should be equal logarithm of 3. It's super easy to prove that because logarithm of 3 is 9. It's a 9. 9, sorry, 9, 9. No 3, 9. And this is 3. And when you apply the property number 6 here on the left hand side, is logarithm of 9 over 3. Que es obvio que es logaritmo 3 because 9 divided by 3 is 3. Okay. And the solution is perfect. Okay. Okay. Okay, guys. We stop.